Jensen Huang, the man whose chips literally power the AI revolution, just delivered powerful commentary on US AI dominance with the hosts of the All In podcast. He revealed a really unexpected, unique advantage that the US has in the global AI race, and commented on so much more, like geopolitics, the industrial rebirth of the United States, and how the US can dominate AI in the future. We're going to break down the entire conversation here, starting with Huang's surprising take on AI impacting jobs, right here on Boardroom Wire. Let's jump into it.
Jobs. We use AI across our whole company. Every single software engineer today uses AI, not one left behind. 100% of our chip designers use AI. We are busier than ever. And the reason for that is because we have so many ideas that we want to go pursue. AI makes it possible for us to go pursue those ideas now that we're not doing the mundane stuff. And so I think the first idea is the more productive you are as a company, so long as you have more ideas, you could pursue those ideas. You'll go after those ideas. And I think that AI, in my case, is creating jobs. It causes us to be able to create things that other people customers would like to buy. It drives more growth, it drives more jobs, all that goes together.
So here, Jensen dives right into one of the most polarizing debates of the current day, AI's impact on employment. While the media oftentimes paints a grim picture of robots stealing jobs, Jensen and the position he's in, obviously he has a different perspective. Straight from the heart of NVIDIA, he reveals that everyone on their team is using AI to ultimately reduce the amount of mundane work they're doing and focus on solving bigger problems. And he reports their team's busier than ever. Now, of course, Jensen does have a multi-trillion-dollar conflict of interest in NVIDIA in discussing this, given they're driving this AI hype. But I do also think he has a point. AI fundamentally is an enabler, especially for people in knowledge work and other fields where there's a lot of tedious, repetitive work that really drains your creativity and energy. I think much like other technologies, AI obviously has the potential to allow us to focus on more creative, higher value tasks and reduce some of that more mundane work.
The thing that to remember is that AI is the greatest technology equalizer of all time.
Okay, explain.
Everybody's a programmer now.
Yes.
You used to have to know C and then C++ and Python, and in the future, everybody can program a computer, right? Just have to get up, and if you don't know how to program a computer, you don't even know how to program an AI, just go up to the AI and say, how do I program an AI? And the AI explains to you exactly how to program the AI. Even when you're not sure exactly how to ask a question, you say, what's the best way to ask the question? And it'll actually write the question for you. It's incredible.
Yeah.
And so it's a great equalizer. Everybody is going to be augmented by AI. Everybody's an artist now. Everybody's an author now. Everybody's a programmer now. That is all true. And so we know that AI is a great equalizer. We also know that it's not likely that, although everybody's job will be different as a result of AI, everybody's jobs will be different. Some jobs will be obsolete, but many jobs will be created. The one thing that we know for certain is that if you're not using AI, you're going to lose your job to somebody who uses AI. That, I think, we know for certain.
Yeah.
There's not a software programmer in the future who's going to be able to hold their own, typing by themselves.
Yeah, you can't raw dog it, no.
No, not anymore.
No raw dog.
Not anymore. You can't raw dog it.
Tell us.
I'll be sure to go home and tell people,
Yeah, exactly.
Hey guys,
That's
you're not going to
really-
raw dog this.
Now, I like Jensen's point here, again, building on this theme of AI as an enabler and using the computer programming analogy, right? Because computer programming has long been something that was really gatekept for just the mathematically inclined crowd, right? So if you weren't highly technical, if you didn't possess strong mathematical skills, you are unlikely to have benefited from the rise of computer programming, software development, etc. But in the future, this is ultimately just going to be a level playing field for everyone, because if AI is the best computer programmer, if AI can tell you how to program an AI, how to program a product, what have you, then it again really levels the playing field. It allows creativity to thrive. That being said, Jensen is also brutally honest that amidst all this optimism, if you are not willing to adopt AI in your job and what you're doing, then you're going to lose your job to somebody who is using AI. It's just that simple. If you're competing with people who are using AI and augmenting themselves with it, you're just going to get left behind. And, as they put it in that video, you can't raw dog it anymore, which is probably true on multiple levels. So with that, let's next get into how Jensen and the team at NVIDIA actually allocate their H100s amidst this extreme demand.
Okay,
How do
so
you
the
deal
way
with
we
that
allocate is
politically?
this.
Yeah.
The way we allocate is this. Place a PO.
Okay.
That's
So
it. Just that's
you
it.
go to the register,
You pay, you get it.
order.
First, first in the old days with Hopper, it happened so fast. It wasn't possible to keep up with the demand. But now we disclose our roadmap to all of our partners a year in advance. Gives everybody a chance to plan with us. They decide how much power and how much data center space and how much CapEx they want to allocate. We plan together. We work on transitions. It's really quite orderly these days.
So here they're talking about the process for allocating the H100 GPUs, which are the most coveted GPUs in the space. It's, what all of these hyperscalers like Microsoft, Meta, Google, Amazon, Oracle are ultimately using to drive forward their AI products and, build out these massive data centers. So obviously Jensen makes it sound simple here. You make a purchase order, you order some of these GPUs, but these GPUs are expensive. So they're ordering tens of thousands, hundreds of thousands of these at a time in the case of the hyperscalers. And those can be as much as, $30,000 a piece. So while I'm sure at some level this is true, I bet you it's kind of like trying to go buy a highly coveted luxury watch. They're going to give preferential treatment to the clients who've spent the most money and bought the most product. So these hyperscalers, what have you, are definitely cutting the line considering they're deploying billions of dollars into these GPUs and are committing billions of dollars well into the future.
Jensen, can you explain to us Elon's tweet and the impact to your industry? He said, we're going to have 50 million H100 equivalents in 5 years from now. And can you just explain to us laymen what that means and how it impacts your business?
One of the biggest observations about AI is that there's the industry of applications that AI has created. It's a revolutionary technology. Every industry will be revolutionized. New applications will be created, so on and so forth. That all the things that we know: agentic AI, reasoning AI, robotics AI, so on and so forth. We know all those things now. Every industry, healthcare, education, transportation, you name it, manufacturing, all revolutionized. The one part that we observed and made a great contribution to is that in order to sustain those applications, you need factories of AI. You have to produce AI. Unlike software, you write the software and that's it. In the case of AI, you have to continuously produce it, generate the tokens.
Right.
In a lot of the same ways that energy production was a large part of the economy a couple, 200-300 years ago, I think it actually peaked out at 30%.
Yep.
There's going to be a whole industry of just producing tokens. And this is going to be the new infrastructure, just as we have the energy production infrastructure, we have the internet infrastructure, and we got to build out that plumbing. And now we have to build out the AI infrastructure. My sense is that we're probably, a couple of $100 billion, maybe a few $100 billion into a multi-trillion-dollar infrastructure build out
Per year.
So this scale that they're talking about here is really kind of mind-boggling if you wrap your head around it. So 50 million H100 equivalents in just 5 years insinuates that the spend is just going to explode for these chips. So for context, many of these large AI labs today operate with hundreds of thousands, maybe a few million chips. And these GPUs, the H100s in particular, cost, let's call it in a ballpark range of 30,000 per GPU. So when you start to talk about numbers like 50 million GPUs, that's over $1 trillion in spend just on, again, the NVIDIA GPU products. So this would represent an explosion in demand for raw computing power to continue these projects like xAI's Grok, the OpenAI models, and so on. What's also interesting here is the way Jensen frames this as really needing factories of AI to power the transformation of all these various different industries from healthcare to manufacturing and so on. And I thought that the analogy he gave of software versus AI was, again, really compelling because it's not something I'd thought about. But with software, once you build it, you're pretty much done. But with AI, you have to continuously produce it through the generation of tokens and powering these large data centers. So AI is not as much software, even though that's the way we typically interface with it. AI is actually more of a good that you have a complex, dynamic process to constantly manufacture it. And that really leads into his other analogy where he talks about how token production is really equivalent to what energy production was for centuries past. So, token production on its own could become a vast portion of the global economy because ultimately we need the same infrastructure that we needed for oil and gas and producing energy to run these big AI supercomputers. And ultimately, this infrastructure needs to continue to be built out with, trillions of dollars being spent on this over the next several years.
What about manufacturing in the US? We asked this question earlier about how it's going. Is the US equipped?
First of all, you guys know you're talking about the United States. I know that there's lots of concerns and everybody's worried about competition and things like that, but we are talking about America here. This is unquestionably the most technology-rich country in the world, and this is the most innovative countries in the world. And the computer industry I have the honor to serve is the single greatest industry our country has ever produced. I think we could acknowledge that.
Yep.
The level of leadership of the computer industry, the technology industry, is just imaginable worldwide. And so this is our national treasure. This is one of our country's assets. We have to make sure that we continue to advance it. Onshoring. Next generation manufacturing is going to be insanely technology driven. Robotics technology, AI technology. You're going to have factories that are going to be orchestrated by AI, orchestrating a whole bunch of robots that are AI, building products that are effectively AIs, right? So you're going to have this in layers of inception. And the amount of technology necessary to create that is really insane. I love President Trump's vision, bold vision, of reindustrializing the United States. That entire band of industry that's missing, we outsource too much of it, frankly. We don't need to insource all of it, but we ought to bring onshore the most advanced, the most economy sustaining, driving, national security enhancing parts of the industry. People always degrade down to tennis shoes. We don't have to go there. We just manufacture chips and AI supercomputers. In Arizona and Texas, we will, in the next 4 years, probably produce about $500 billion worth of AI supercomputers. That $500 billion worth of AI supercomputers will probably drive a few $1 trillion worth of AI industry.
Right.
And so that's only in the next several years. And they're doing great. Arizona's doing great.
So the first thing that obviously stuck out to me here is Jensen is super pro-America, which I probably should have expected, but I hadn't heard him speak about the US kind of this glowingly, but his confidence, it really sounds a little bit like Trump, which I think we'll talk a little bit about in a minute here too. But he also reinforces this idea that technology is really our crown jewel in the United States. And it's ultimately a massive strategic advantage. And again, he calls it, the computer industry more broadly, the single greatest industry ever produced. So clearly he's very bullish on the onshoring of American manufacturing, but he also segments it, right? So, things like sneakers, clothing, what have you, Jensen's not really interested in onshoring, but things like AI supercomputers, that's what we want to be building in the United States, according to him. And ultimately, the increasing reliance on AI and robotics in manufacturing, Jensen believes can be a driver for onshoring a lot of this back to the United States. So again, very kind of Trumpian view, if you will, that we're hearing from him. And I think you'll hear a little bit more why in a second. So let's jump into the next clip.
So there's a lot of talk about American competitiveness today, and the White House rolled out its AI action plan, and NVIDIA is making very big bets on the United States. And so as a CEO of a global company, what do you see are America's unique advantages that other countries don't have?
America's unique advantage that no country possibly have is President Trump. And let me explain why. One, on the first day of his administration, he realized the importance of AI and he realized the importance of energy. For the last, I don't know how many years, energy production was vilified, if you guys remember.
Yeah.
We can't create new industries without energy. You can't reshore manufacturing without energy. You can't sustain a brand new industry like artificial intelligence without energy. If we decide as a country the only thing we want is IP, to be an IP only, a services only country, then we don't need much energy. But if we want to produce things, something as vital as artificial intelligence, then we need energy. And so I'm just delighted to see to accelerate AI innovation, to accelerate the growth of energy so that we can sustain this new industry and go after the new industrial revolution.
So this part just absolutely shocked me when I heard it. And again, maybe he's spoken about this and I hadn't heard it before, but he is shockingly pro-Trump here and actually positions President Donald Trump as the unique advantage for America in the AI race. So I know it's become a little bit more in vogue lately for some of these tech titans to speak, about Trump, and maybe he's again just kissing the ring because that's who's in charge. But I think he also gave a kind of important glance into how important he believes energy production is in AI, right? So energy production is absolutely critical path for building out and powering all of these massive data centers that make AI possible. And I think that Trump's rhetoric on being pro-energy, the kind of drill baby drill rhetoric, if you will, is critical for token production, powering these massive data centers, and ultimately energy independence and the AI revolution are tightly coupled. So I think, again, maybe it's less about politics and more just how critical a pro-energy agenda is to the AI ecosystem. But either way, it's a powerful and really provocative statement for Jensen to make, even at a, kind of pro-Trump event, if you will.
Can you talk about physical AI versus data center AI?
Yeah, excellent. Everything in the world that moves will be autonomous someday. And that someday is probably around the corner. So everything that moves. We already know that your lawnmower is going to, who's going to be pushing a lawnmower around? That's craziness. Unless you want to. I mean, it's, And so I think everything that moves will be autonomous. And every machine, every company that builds machines will have two factories. There's the machine factory, for example, cars, and then there's the AI factory to create the AI for the cars. And so maybe you're a machine factory to build humanoid robots. You need an AI factory to build a brain for the humanoid robot.
Right.
And so every company in the future, in fact, the future of industry is really two factories.
Yeah.
Tesla already has two factories, right? Elon has a giant AI factory. He was very early in recognizing that he needs to have an AI factory to sustain the cars that he has. Now he's got AIs in the car, but in the future, instead of, I imagine that in the future, instead of a whole lot of people remotely monitoring air traffic control, it'll be a giant AI that's doing the remote control. And then only in the case that the giant AI can handle it with a person come in to intercept. And so I think you see that these industries in the future, every industrial company will be an AI company, or you're not going to be an industrial company.
So a few years ago, this might have sounded like sci-fi, but I think to people now, this feels, closer than ever that maybe we'll be in a world where pretty much everything is autonomous the same way Teslas are driving around. Like Jensen says, you probably don't need to operate your lawnmower in the very near future. But the real meat of his argument, and what I thought was interesting, is this two-factory concept. So if you think about it, traditionally, if you built cars, you have one factory, the physical one churning out all of the vehicles. But Jensen points out that in the future, every machine building company will also need two factories. So basically one for the existing process of churning out the physical machines, and the second dedicated to building out the AI that's ultimately going to be the brain for those machines. So just like Jensen said, employees and workers need to embrace AI, same thing for the manufacturing industry. Anyone building machinery is going to need to embrace AI as well.
There was a couple of moments throughout the course of this year where people almost threw in the towel and said, oh, we lost to China, right? There was the DeepSeek moment. Then maybe last week, there was this Kimi model moment. But then it kind of fizzled out. Can you just explain to us how big of a threat they really are in terms of getting to supremacy, getting there first, to whether it's AGI or superintelligence?
Yeah, excellent question. The Chinese AI labs are the world's leading open model companies. They offer the most advanced open models. Open source is fantastic. If not for open source, we know startups won't exist. And to the extent that we believe that the future industry is going to be today's startups, they're going to need open source models. And DeepSeek, when it came out, it was a great win for the United States. It was an incredible win. What people did, and two reasons. First, imagine if DeepSeek came out and it only ran on Huawei. I just want us to pretend. Use that thought experiment.
Totally.
Right? Now you got two parallel universes.
No,
exactly. Could you imagine if QN came out and it only worked on non-American tech stack? Yeah. Could you imagine if Kimi came out and it only worked on non-American tech stack? And these are the top 3 open models in the world today. It is downloaded hundreds of millions of times. So the fact of the matter is, American tech stack, all over the world, being the world's standard, is vital to the future of winning the AI race. You can't do it any other way. We've got to be, as you know, any computing platform wins because of developers.
So I think the way Jensen kind of inverts the question around the Chinese labs and what they're doing on the AI front is also, again, a really compelling perspective. Everything he said has been, pretty insightful, to be honest. So these Chinese labs are leading in the open source community, which is absolutely critical, especially for startups, like he mentioned, because they've got a lower barrier to entry. It's easier to embrace than some of these other models. But I think also the example he gives of how fortunate we are that these models are open source from an American perspective is also really true, right? Because if DeepSeek just ran on Huawei as an example, no one else would be able to benefit from that innovation. And I think his broader point around the American tech stack needing to embrace these other models is a really potent one as well, because you've heard multiple people in the political spectrum and business world talking about it, but ultimately the United States needs to be able to do business with China in the future if they actually want to win. There's too many programmers in China, there's too much software being built there. So really, although it's been, really robust competition to this point, ultimately in the future, the United States needs to be able to sell their products into China and vice versa for this to work and ultimately to be the dominant player within AI globally.
It used to be NBA players signing $300 million contracts. Now it's, model researchers. And then there was a post this weekend that said that there was a person that was offered $1 billion over 4 years by Meta. Now, if that's happening at this layer, why hasn't it happened at your layer? Because you are the enabler of all of that. And how do you think all of this human capital is going to actually play out?
First of all, I've created more billionaires on my management team than any CEO in the world. They're doing just fine. Okay, and so, and they're doing. Don't feel sad for anybody at my layer. But the big idea though is that you're highlighting is that the impact of 150 or so AI researchers can probably create, with enough funding behind them, create an OpenAI. It's not a
150 people.
Yeah, well, DeepSeek's 150 people.
Right.
Moonshot's 150 people. Right?
Crazy.
And so, look at the original OpenAI was about 150 people.
Yep.
DeepMind, and they're all about that size. I think there's something about the elegance of small teams, and that's not a small team. That's a good sized team with the right infrastructure. And so that kind of tells you something. 150 people, if you're willing to pay, say, $20 billion, $30 billion to buy a startup with 150 AI researchers, why wouldn't you pay one?
Right.
So obviously, Jensen makes a good point here. None of us need to be feeling sorry for anyone working at NVIDIA, especially not the members of the management team, considering if you owned any amount of that stock over the last several years, you are doing very, very well. But I do think this point that Chamath brought up was interesting, right? Because we've seen a ton of deals recently with AI companies being bought for exceptional sums of money. You have Alexander Wang from Scale AI, who got brought on by Meta for like $15 billion. So there are absolutely massive, just basketball money deals, really more than basketball money, being offered to researchers these days. And is that actually going to pay off? Like, is that investment worth it? And clearly, Jensen believes it is. And I thought that was another really provocative statement he made, that 150 really good people with the right compute infrastructure and investment behind them can probably create a new OpenAI. And, you know, he brings up DeepSeek, the original OpenAI team, the Google DeepMind team. All of these were relatively small teams in the 100 to 200 person range. And ultimately, that's what it takes to build one of these frontier models. And for me, the big question with that is, well, if that's actually true, then how much defensibility do you really have as a business at this model layer? Because if these computing costs come down, ultimately hiring 150 cracked engineers to build a new OpenAI does not look nearly as expensive as it once did in 2020 or earlier. With that being said, I think Jensen's main points around US AI dominance, really investing in the underlying infrastructure and having a concerted effort at the national level is going to be critical to, again, winning the AI race as the United States. So with that, I'm going to wrap things up. If you found this breakdown valuable, make sure to like this video, subscribe to Boardroom Wire for more in-depth analysis, and hit the notification bell so you don't miss our next deep dive. Thanks for watching. See you on the next one.